In this video, we're discussing the rate of change of graphs and equations. An important note is that with graphs, we need to remember to use the rise over run concept. It's still thinking about the change in y over the change of x, but rise over run is a little simpler way to discuss that. So when I have a linear equation and it's graphed, you'll notice that this has a rise, or upward movement, over our run. So I move up, in this case, 2 times, and to the right 1 time. So my slope would be 2 over 1. I can see that's consistent by going up 1, 2, and over 1. Up 2, over 1, up 2, over 1. Now let's say that I didn't realize that it was up 2 and over 1 because this point wasn't there, and I skipped straight here. I should be able to see that I can still notice that I'm up 1, 2, 3, 4 now, and over 2, which still simplifies to this 2 over 1. Sometimes our slope is moving in a negative direction. When I am finding the slope of a line, I'm always moving from left to right, okay? Left to right. We do that because we read from left to right. In most countries, most languages, we go from left to right. So I want you to also read your math in that way as well. So we start at any point, for example, this point up here. And in this case, I'm going to go down for my quote-unquote rise, okay? In this case, it's falling, but I went down 2 units, so -2. Direction and negatives matter. And then I'm going to move over 1 time to get to my next point. But since I'm moving to the right, right is positive. So I have down 3 and to the right 1. I'm sorry, down 2 and to the right 1. So you'll notice that we moved that twice and then over once. We also have equations. There is a particular type of equation called slope-intercept form that is in the format y equals m times x plus b. You'll notice here that m is with x, y is isolated by itself, and b is off on the side. The different components here, y simply represents y, m represents our slope, or our rate of change, and then, of course, x represents x. And b is the beginning, or the y-intercept. We'll get further into y-intercept at another time. The really important thing to notice is that m is immediately next to x. They're being multiplied by each other. So when I'm looking for an equation, slope, whatever number is with x, that right there is my slope, or my rate of change. It's always being multiplied by x. So I have a couple of examples here. Firstly, I have y equals mx plus b. So I'm looking for m. How it moves is what the slope is discussing. So m in this first example is 1/2. For the second, I don't have a fraction, but I'm still looking for whatever is next to x, whatever is being multiplied by x. So I have -3 times x, and that is my rate of change. In this case, it's negative, and I won't include that x part when I write my final answer. So -3 or -3 over 1 is my answer. A couple of slightly unique circumstances here. So I'm looking for whatever is next to x. In this case, it's 2 or 2 over 1. That is my final answer. But here in this last one, I don't have any x written. It's just y equals 4. No x means that there is a slope of 0. That's the only way to get rid of the x, right? Because y equals 0x plus 4 gets rid of that x, because 0 times x cancels it out.